So equation of projectile is a parabola. We need to prove. Projectile means if any object is thrown from the ground, if it is launching on the same, this is called oblique projectile. Oblique projectile. For oblique projectile, the path is called a parabola. So the path of the projectile is parabola that we need to solve. Mathematically, equation of parabola is y is equals to ax plus bx square. This is the equation of parabola. In this way, we need to adjust our equation. So let us take an object is thrown with initial velocity u, angle is theta, and it is dropping like this. The component along the theta side is u cos theta, we know, and the other side is u sin theta. Let us take displacement along x-axis is x. Displacement along y-axis is taken as a y. It is moving up, the gravity is downside, so acceleration is minus g, remember this. So at the highest point when it comes, the y component of this will becomes 0 because the velocity slowly decreases. This u sin theta becomes 0 at the highest point, but this x component will be same, u cos theta. How this 0 and u cos theta has come, let us prove this. First, to final velocity we need to prove. This is a decelerated motion. You can apply equations of motion u plus at. So from here to here, u plus at or v square minus u square is equals to 2as. S is equals to ut plus half at square. You can use any of these equations. This is a velocity at the highest point. This is a velocity initial point. This is initial velocity u along y-axis. This is a final velocity v along y-axis. So this will be vy, this will be uy, and this will be ay, and this will be t. So acceleration is acting downside, so a is minus g, time is t. So vy is equals to u sin theta, uy is u sin theta, ay is minus g t. So slowly see here, initial velocity is neglecting with some value. So slowly when it goes up, the final velocity becomes 0. And similarly for Vx, if you do, Vx is equals to ux plus axt. Vx is a final velocity at the highest point. Ux is a initial velocity at along x-axis, that is u cos theta, ax is 0 into t. Only acceleration is acting at y-axis. There is no acceleration along x-axis, that's why it is 0. So Vx is equals to u cos theta. So anywhere if you take, the x component will be same, it is irrespective of time, but when it is moving up, this will be decreasing, u sin theta minus gt. So once you come at the highest point, these two values will be equal. At the highest point the velocity will be 0. Right, now we'll take this equation and we'll write for x-axis and y-axis. See here, I am giving the components for this and this and this, not to the time, because time is a scalar. These all are vectors. Give the components along y-axis, only vector components. Velocity is a vector, velocity is a vector, acceleration is a vector, time is a scalar, don't give component. Similarly, vector components only given suffix, time is not given suffix because it is a scalar. Now we apply this equation. S is equals to ut plus half at square. Here also displacement along x-axis is sx, initial velocity ux, time is a scalar ax. S is equals to ut plus half at square. Give same here, displacement along y-axis, velocity y-axis, acceleration y-axis. We know ax is 0, ay is minus g. So substitute that. Sx is x, we have seen. Ux is u cos theta into t. Ax is 0, so this remaining term is 0. X is equals to u cos theta into t. and the time is equals to x by u cos theta. Take it as equation 1. Here sy is a y, uy is a u sin theta, time is a t, plus half acceleration along y-axis is minus g into t square. Now substitute t value in this. So y is equals to u sin theta, t value x by u cos theta minus g by 2, t square is this square, x square by u square cos square theta. So y is equals to u cancel, sin by cos is tan x, tan theta x minus g by 2u square cos square theta into x square. So we got this equation. This is called equation of parabola. It looks like ax minus bx square. This is the equation of parabola. You may be having doubt here. It should be plus, right? It may be plus or minus. It is the equation of parabola. So equation of parabola is identical to equation of projectile. So both are comparable. So we can say parabola and projectile are similar. Our projectile motion is in the shape of parabola, hence it is proved.